Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Gas Regional Constraints by Senny K. And the gas is usually a acronym which stands for Generally Approachable Sudokus. So these tend to be of the very easy type. So when someone says they're doing a gas Sudoku, that's what you know. You know it should be fairly easy to do because it should be generally approachable. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have regional constraints, where every constraint type may contain no repeated digits anywhere in the puzzle. So that means any constraint that has the same constraint type, you cannot have repeats on. Oh, so I guess I should have used this as you can't have repeats in any row, column, or box version. But anyways, so that means across all X puzzles, you cannot have repeats. Across all lines that are the same color, you cannot have repeats. Along arrows, you cannot have repeats. Well, that's already given. For all white dots, you cannot have repeats. And for all black dots, you cannot have repeats. So keep that in mind. We have tentropy, where every set of 4 adjacent digits on the hollow peach line must contain a digit from each of the X pairs, 10 pairs, subsets of 1 and 9 as a subset, 2 and 8 as a subset, 3 and 7 as a subset, and 4 and 6 as a subset. A 5 may not appear on a tentropy line. So that an example of this would be something like, say, 1, 8, 6, and 3. Along this, every 4 adjacent digits on this line, you have a digit from the subset 1, 9, which is 1, a digit from the subset 2, 8, which is 8, a digit from the subset 3, 7, which is 3, and a digit which is from the subset 4, 6, which is 6. So that's an example of how tentropy lines work. We also have German whisper lines, where neighboring digits along a green line have a difference of at least 5. And I will call them whisper 5 lines because that's my preference. I did not come up with this. This was someone that a setter came up with, and I thought it was a brilliant idea because it's easily extensible to other different rules. You could have whisper 6 lines, whisper 8 lines, whisper 2 lines. That's the reason why I use it. You can still call them German whisper lines. That's fine. I mean, everybody has their own preference, right? Anyways, as an example of a whisper 5/German whisper line, if this were for, say, we had a 3 here, this had to be 8 or 9 to maintain, sorry, not to maintain, because those are the only digits which are 5 or more away from 3. So that's an example of how German whisper/whisper 5 lines work. We have arrow, where digits along an arrow sum to the number in the attached circle. So for example, if this were, say, 3 and 4, this would have to be 7, because the digits along the arrow must equal the digit that's in the attached circle. And that's an example of how arrows work. We have Kropke dots, where digits in cells joined by a white dot are consecutive, and digits in cells joined by a black dot are in a 1:2 ratio. That is, one digit will be double the other, and not all dots are necessarily given. So, for example, if this were, say, a 6, this would have to be a 5 or 7 to make sure that these digits are consecutive. If we had a 2 here, this would have to be 1 or 4 to make sure that they are in a 1:2 ratio. And those are examples of how crop key dots work. White dots, white crop key dots, and black crop key dots. And finally, we have X, where digits and cells joined by an X sum to 10. And not all X's are necessarily given. I prefer adding that necessarily because not all X's are given implies that there are other scenarios where you do have 2 digits adding up to 10. Guaranteed. And you won't necessarily want that. But as an example, say you had a 3 here, then this would be 7, because these digits must add up to 10, because there's an X between them. And remember the regional constraints, so that will be very important. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, let's start here. We have 3 digits, sorry, one digit that's going to be in a 1-to-2 ratio with 2 other digits. The only 2 digits that can fill that criteria are 2 and 4. So this is guaranteed to be 2 or 4, and that's going to be in a 1-to-2 ratio with 2 is going to be with 1 and 4. 4 is going to be with 2 or 8. So we're guaranteed in this regional constraint of this rule to have a 2 or 4 here, right? If 2 is here, this is guaranteed to be 1 and 4. If this is 4 here, that has to be 2 and 8, which means this is 2 and 4 all across this black crop key dot. So you cannot have a 2 or 4 in any other black crop key dots. So this cannot contain 2 or 4, which eliminates 1, 2, 2, 4, and 4, 8 as a pair. So this has to be a 3, 6 pair. That eliminates to add up to 10 here, 3, 7, and 4, 6. So this is 1, 2, 8, or 9 here. If this were a 4 in either of these scenarios, it would have to be next to 2 9s. But because of the regional constraints where we can't have repeated digits for a constraint type, a rule, therefore, you can't have 2 9s there, so this can never be 4. Therefore, this can't be 1 and 4 surrounding 2. It must be 2 and 8 surrounding 4. So this is a 2, 8 pair. Let's see. This can no longer be 2, 8 or 4, 6. So this must be 1, 9 or 3, 7 to add up to 10. You can never have 5 on a whisper 5 line. And the reason why is subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. If you add 5 or more to 5, you get 10 or more, which is not a digit. So 5 cannot appear on whisper 5 lines, 5 can't be next to an X, and 5 cannot appear on a tentropy line. So where's 5 in row 5? It has to be here. So this is 5. On a whisper 5 line, 6 can only be next to 1. So 6 cannot be either of these digits. Where's 6 in row 5? It has to be here. So this is 6, which means 6 can never appear on another tentropy line. So this can't be 6, that's 3, which makes this 6. We don't know what these are. So this could be 1, 9, or 3, 7. Either of those work. We need to have a 6 somewhere. So these digits on the whisper 5 lines are all different. We need to have a 6 somewhere there. 6 can only be next to one unique digit on a whisper 5 line. And it can only be next to 1. So 6 can't be here. 6 can't be here because that's next to 2. 6 can't be any of these. 6 can't be here because it's next to 2 unique digits. So 6 has to be here. So this is 6, which makes this 1. Because 6 can only be next to 1 on a whisper 5 line. 1 can, out of 2 or 8, 1 can only be next to 8. So this is 8. This is 2. 2 has to be next to 1 or... sorry, 8 has to be next to 1 or 3 on the Whisper 5 line, and it can't be 1 because we can't have repeats because of the regional constraints. So this is 3. That means this cannot be 3, 7 as a pair. It's 1 to add up to 9. It's 1, 9. So this can't be 1, 9, or 3. It's 7. And we need a 4 and a 9 on the Whisper 5 lines. This can't be 4, so this must be 9, which makes that 4. And the region constraints are all satisfied. This must be a different 1-9 set than this. And since this is a 1-9 set, this can't be 1 or 9, so this is a 2-8 pair. We need to have a 4 somewhere on the regional constraint because you can't untentropy lines. So we have 1, 9, and 2, 8 already for the x's, so this must be 3, 7, or 4, 6. This can't be 6 because of 6 in the row. This must be 3, 7, or 4, 6 also, but again, this can't be 6 in the row, so this can't be 4. Okay. These must be... so... one of these is in the 1-9 set, and one of these is in the 2-8 set. So this is 1, 2, 8, 9. This cannot be 1 or 8, so this is 2 or 9. This cannot be 9 here, so this could be 1, 2, or 8. These are from 3, 7, and 4, 6. And this can't be 4 or 6, so this must be 3 or 7 here. 3 cannot be on the tentropy line because of regional constraints, so this must be 7. And this can't be... this is 4 or 6 here. And it cannot be 6 because of 6 on the regional constraint is already on the tentropy line, so this is 4. This 7 eliminates 7 in the rest of the row. So this is 3 or 4, which means this can't be 3 or 4. Because that would guarantee this has to be 6 or 7 here. 6 or 7 is consecutive with 5 through 8. But it cannot have a 6 or 7 because of regional constraints of the white Kropke dots. So this is 5 or 8. And this must be 5 or 8. And it cannot be 5 because of 5 in the column. So this is 8, which makes this 5. This 8 eliminates 8 here, so that's 2, which makes this 8. 8's only consecutive with 7 out of 6 or 7, so this is 7, 3, which makes this 6 and 4. 8 cannot be on the regional constraint, or cannot be on the, tentropy line because of regional constraints, so this can't be 8. We have 5, 6, 7, 8 on the white Kropke dots. 9 can only be consecutive with 8. And we already have the 8 used on a white Kropke dot. So therefore, these must be 1 through 4 left on the white Kropke dots. So this cannot be 4, which means this can't be 3. And this can't be 4, so that can't be 3. Okay. This digit cannot be 4, 5, it cannot be 6, and it has to be the sum of 3 unique digits. So it must at least be 6, and that's therefore 7, 8, or 9. Um, hmm. What about this? Remaining... okay. Where is 7 in column 1? These are filled out. Cannot be here because of 7 in the box, so it has to be one of these 3. For 3 digits to add up to 7, 8, or 9, it has to be at most 6 as the highest digit, and this can't be 6, so this is 1 through 5 here. No 3 or 4 here because of 3 or 4 in the column. Can't be 2 because of 2 in the 3 or 4 in the box and 2 in the column. This is interesting. Can't be 4 because of 4 in the column. So one of these 2 is a 4. That's interesting. If this is 4, obviously this is 3. If this is 4, this cannot be 3 here because 1 and 2 have to be consecutive and 3 or 4 have to be consecutive. So if this is 4, this would be a 1-2 pair, and so this would have to be 3 or 5. But 4 and 5 plus another digit can never add up to a digit, so this would be 4 and 3 if that were the case. So either this is 4 and that's 3, or this is 4 and that's 3. So we're guaranteed one of these digits is a 3. We're not sure which in this box. Remaining digits in the central box are 3, 5, 6, and 7. Okay. This can't be 3 or 6, so we now have a 5, 7 pair in the central box, which eliminates 5 and 7 in the rest of the box. So this can't be 5 or 7. This 6 eliminates 6 here, so this is 3, which means this can't be 3. That's 6. Okay. That means the remaining digits in column 5 have to be 1 and 9. So we have 1 and 9 here, 1 and 9 here. We have a 1, 2, 3, 9 quadruplet in row 7, which eliminates 1, 2, 3, and 9 in the rest of the row. So the remaining digits are 5, 6, 7, 8. This can't be 5, 7, 8 because of 5, 7, 8 in the column. So this is 6. That leaves these as 5, 7, and 8. 5, 7, 8. No 7 here. 5, 7, 8. Interesting. Remaining digits in column 9. We have 1, 2, 4, 9. No 1 or 4 here. 1, 2, 4, 9. No 9 here. 1, 2, 4, 9. 1, 2, 4, 9. And 1 and 2 cannot be in the circle because they can't add up. 2 digits can never add up to those. If you had a 4 here, that would guarantee this is 1 and 3, but then this would not be consecutive. 2 would not with anything else because of the regional constraints. So this can't be 4. This is 9, which eliminates 9 here. So that's 2, which means this can't be 2. This is 1. Therefore, this can't be 9 because this tentropy line has to contain 1 from each subset. 1, 9, 2, 8, 3, 7, and 4, 6. And we're missing 2, 8. So this must be 2 here. 1 eliminates 1 because of regional constraints on the tentropy line. So this is 9, which makes this 1. This can't be 9 anymore here. So this is 7 or 8, which means we are guaranteed a 1 on this arrow, right? It's either 1, 1, 2, 4 adding up to 7, 1, 2, 5 adding up to 8, or 1, 2, 1, 3, 4 adding up to 8. So you cannot have a 1 in the rest of the row. This can't be 6. This 2 and 1 eliminate 1 and 2 here, so that's 4. This can't be 2, 4, or 9, so this is 1. So this cannot be 1, 2 as a pair, therefore that forces this to be 3 and 4. That means this cannot be 3 here, and this cannot be 4 here. So this must be a 1, 2 pair here. 1 eliminates 1 here, so that's 2 and 1, which eliminates 1 and 2 in the rest of the box. This has to be 4, so this must be 3 and 1 adding up to 8. 8 eliminates 8 in the rest of the box, so this is 5. This can't be 5 or 8. It's 7. That eliminates 5 or 7 here, so that's 8. 1 eliminates 1 here, so that's 9. This cannot be 1, 8 adding up to 9, or 3, 6, or 4, 5, so it's 2 and 7. So we have a 2, 7 pair here. That means the remaining digit in row 9 is a 5. Remaining digit in this lower right-hand box is also a 5. The remaining digit in the lower left-hand box are 6 and 9, and this can't be 6 because of 6 in the column, so this is 9, which makes that 6. Remaining digits in row 8 are 7 and 8, and this can't be 7 because of 7 in the column, so this is 8, this is 7. Remaining digits in column 1 are 2 and 3. This can't be 2 because of 2 in the row, so this is 3, and that's 2. Remaining digits in column 4 are 3 and 5. Oh, this 9 also eliminates 9 here, so it's 1. This can't be 5 because of 5 in the row, so that's 3 and 5. Remaining digits in column 6 are 4 and 9. So we can just place a 4, 9 pair here. Remaining digits of row 4 are 5, 7, 8, 9. And this can't be 7 or 9, so this is 5 or 8. 5, 7, 8, 9. 5, 7, 8, 9. This can't be 5 or 8, so it's 7 or 9. And this can't be 5 because of 5 in the box. That leaves us as 7, 8, or 9. Cannot be 9 because of 9 in the row. So this is 7 or 8. Remaining digits of column 3. 1, 2, 8, 9. Cannot be 1, 2, or 9 because of 1, 2 in the box and 9 in the row. So this is 8. That leaves this as 1, 2, 9 here. This 8 eliminates 8 in the box, so this is 5, which eliminates 5 in the row, so it's 7, which eliminates 7 in the row, so it's 9. That makes this 8, which makes this 7, which makes this 5, and therefore this is 6. No 1 remaining here, no 2 remaining here. 7 eliminates 7 here, so this is 2, that's 7. Remaining digits in column 2 are 3, 7, and 8. This can't be 7 or 8 because of 7 and 8 in the row, so it's 3. This can't be 3 or 7, so that forces this to be 8. That makes this a 7. Remaining digits in column 7. We have 2, 4, and 6. This can't be 4 or 6 because of 4 or 6 in the row, so this is 2. This can't be 6 because of 6 in the row, so that's 4, which makes that 6. 2 eliminates 2 here, so that's 9. Which eliminates 9 here, so it's 1, which means this can't be 1 or 9. It's 2. 4 eliminates 4 here, so it's 9 and 4. That leaves this digit as a 9, this digit as a 1, and this digit as a 5. I hope you enjoyed this puzzle. I did. And I will rate the puzzle. I hope you enjoyed this episode of Learn How to Sudoku. And I'll see you next time on Frank Puzzles. Take care.